Megan, are you okay? Megan, sorry, don't worry. Hey, you going home? Home. Bye. Take care. Get around soon. Hey, you're back. Okay. Let's start. Okay, what happened? Megan never bring it. Half your worksheet. She used for reference. I can't say. All have or not? Who don't have? If you don't have, you again. Whole day. I'm going to go and tell our track teacher already. Huh? I also got $1 million in the bank. I just haven't earned it. I also got about 3 million in the bank. I just forget it's in rupee. Okay. Alanis, must give me soon. Okay. Bye. Take care. Get well soon. Indonesian rupees. I don't know. I only know how to use it as a joke. My math was correct. Okay, so let's start. Okay, okay, practice set 3. This is way overdue. So can you look at the first one? You are supposed to sketch y equals to modulus x plus 2. In case you do not know the question, this is what the question look like. Okay, you are supposed to sketch y equals to modulus x plus 2. Okay, so things to note, you need to be able to list out the endpoint. So take note that for a question like this, endpoints are important. 30 points are important. So make sure you have all 3. Okay? Okay, so far? Yes? Yes. So because they ask for the coordinates of the vertices. So this one is the vertices. So these one are the endpoint. Okay. So all these are what we call the endpoints. These are what we call the endpoints. And these are the vertices. Not to worry. If you haven't do, you can literally do it with beside you now. Okay? Yeah.
We just write -2 is fine. Do we have to write?
No, they need coordinates. So guys, remember, I need coordinates. You cannot just write -2, okay, because they ask for coordinate. Coordinate means what? Two things come in pairs. I must give you a pair. Okay? Can make sure you have the turning point. And this has to be lower than this. How I mark 4, some of them put the same height. Okay, so you just think, okay, not a problem. Question? Who is not here today? Javier. Wei Xiang is here. Evie. Edison. Where is Edison? 6. So 3 people today. Okay, correct. Okay. No one looking at the screen, Calling once. Okay, so I go on. How come your locker is always not locked? I realize. Your PMs don't like to lock your locker. Honest? Yeah, mine also honest. Mine is second upper. Right. Okay, question 2. Let me go and see. I scared you forget. Next year I give you back. Why you never put? You forget. You forget. I will teach you to remember. Do you know how I remember my wedding anniversary or not? You just have to forget it once. After that, the pain will make you remember. Okay, so anyway, after my wife came in, after that I remember. Okay, kidding. Okay, so anyway, please don't forget. Okay, possible values of C. Okay, so yes, so I substitute x equals to 1, y equals to 2. Okay, you know that a modulus graph will be a V shape, right? So you sketch the possible graph. You start in x equals to 1, you start in y equals to 2. This renders you a modulus equation. Yes. You can do that. But chances are when you draw both graphs on the same axis, it will be quite awkward not to put the intercepts. So generally, if they never ask, if it's possible, my tendency is if they never ask for the same diagram, I draw a different diagram. Because whenever they ask me to draw two graphs, if I draw the same, then it will look weird for me not to put the axis intercepts. Okay? So, yeah. What do you half the graph? Oh, no marks. No marks. By no marks. The whole graph must be 1. When you draw half the graph, it's not. It can be misunderstood as another graph. It's not a complete graph. The complete graph is together, 2 parts. Okay? Okay, right? So far, okay? Have to be equal. Both, yeah.
They say that the x1 x equal to 1 y equal to 2, right? So we have to write as coordinates in the graph.
Yes, it's here. Okay. X-intercepts. This is the x-intercept. So x-intercept is here.
Something in x plus 2.
Oh, do I need to write coordinates?
I don't want. Because this is about 2, 1.
1, 2 is here. Okay, so 1, 2 is here. 1, 2 is here. Okay.
That's 0.
Huh? Wait. As x equals to 1. 1. Oh, sorry, wrong. My bad. So first is y equals to 2x. If y equals to -4, y equals to 2x plus 2 plus 4. This is 2. This is 2, 0. Then 1, 2 is here. No need. It's fine. No need, it's fine. But if you ask me, the vertices I must coordinate. Okay, tendency is I just try to put coordinates all the time. Okay. So listen, Jaden Lloyd, you got to do your practice set. Okay. So just remember, the question never say, it does say label in the set. Usually, I always leave a code. This is a good practice in your mind. It's a good practice for you. Okay? Can I? Okay, question 3. Question 3, for support, I just put the question beside you, so you take a look. This is the question. My guess is it seems okay lah, huh? This is question 3. Yes? Oh, thanks. Wow, very good. Wow, it's wonderful that you all can correct. Yeah. Okay. Question 3. Question 3, x squared plus 2x minus 3. So this graph will be a U shape for sure. But if you are doing a modulus, then it will be a like a inverted Ronald McDonald shape. Okay. Not so loud. Okay. So -1 and 4, Because originally the coordinate is -1, -4. If you're not sure, then what you can do is draw original graph. If not sure, draw y equals to x squared plus 2x minus 3 first. Okay, then you're going to get the graph. 1 second, for sure. -3, 1, -1, -4. Okay, this is the original graph. Then from here, then you reflect the original graph from here to here. So far, okay? Yes, Joshua. Huh? Yes, generally I use pencil. I use pencil. Pencil more forgiving. You use pen, your correction take very long to change. Oh, okay. So then after that, you know that any part that's below is going to be reflected. Once you reflect, y coordinate changes from negative to positive. So far, okay? Can now don't visualize the drawing. You need to do it properly. Put some effort, do it properly. No pass equal, axis label. Some of you, the boys, no offense, you draw graph, never use hand, never use ruler, never use pencil. Just draw one. Then it won't be so easy to mark. Okay? Can it needs to be a beautiful graph. Okay, just like this. Yeah. Okay, look at this graph. Like that, very good. Like that, very good. Okay. Hey, this one, okay, this one's a bit, it must be curved out. Curved out. Can you see the screen? Some must be curved out. Some looks a bit like our shoe. Look at the line, that, very good. This one can be better. Okay, this student never use ruler. This one too straight. This one maybe curvy more, a bit more curvy. Okay, can Okay, now I go to for which it has two solutions. It means that I'm talking about the values where I have a horizontal line. So I'm referring to k. This is y equals to k. You look at it as a horizontal line. And this horizontal line, it cuts the curve at 2 points. Because these 2 points will ensure there are 2 solutions. So if you observe this curve, you can see at k equals to 4, y equals to 4, I can cut 3 points, right? So that is not my answer. That's why I do not want k to be 4. Okay, I want k to be more than 4. Example, y equals to 5. That's why you see my k must be more than 4. Above 4, above the turning point, horizontal line cut 2 times. Where else is where k equals to 0, y equals to 0. Basically, k is 0. You will see that again, I cut 2 points. Okay? Here and, sorry, wrong. Here and here, here and here. Okay? Y equals to 0, y equals to k, where k is more than 4. Then I will cut 2 points. Okay, also that is part A. Yes?
You have to reject like less than 0 because of here. You have to reject that.
No need. Because they only ask for values of k. You're asking me to show you, so I'm just like picking and steps. So the equation of the tangent and its y-intercept. Where's the y-intercept? Y-intercept is here lah. Oh, this is the y. This is what they are asking you for part B. Okay? So you remember how do we find the tangent in this case? Come again? Good question. So this is a question you all might get stuck in. The similar example, I think 3.2 in the books. So you need to find a gradient function, right? To find a gradient function, you need to remove the modulus. So when I remove the modulus, is it positive or is it negative? Now, don't forget, Mitra, this modulus, right? This graph here is actually negative. Because originally, right, the positive part is here. This is y equals to x squared plus 2x minus 3. If fx is negative, modulus of fx is actually negative fx. Agree? So remember this part was negative, it was reflected. Can? That is why my derivative here is found from the negative portion. Is everyone okay with that? This is a tricky part. I hope you all got it. Am I okay? I said okay. You will? Yes. Yes, some of you all looking at the screen and moving your green pen, so I'm going to pause a while. After this, I can airdrop you the whole thing. I'll put on the Google Classroom. Oh, yeah. Okay. B. Oh, okay. So if you all remember, okay, if you all remember, let me just put it here. If you all remember, the modulus definition is that y equals to modulus of fx, right? It is either equals to fx or negative of fx. So this part, okay, originally the fx is there, right? But this portion it was negative, right? That's why if I want to take modulus, this part this is negative of fx because I've reflected. why the boys so harsh to each other nowadays? Just be kind or not be kind. Yeah, can I? Yeah lah, you shouldn't say that. Yeah lah. Okay. Yeah lah, you see now irritated. Okay, so anyway, so that's why we see that this portion here is negative, taking negative fx. Oh, so negative, I find the gradient function also negative, then I substitute in. What is this point? This point is none other than, I'll do the sub x equals to 0. You can see 0, 0 minus 3, right? Modulus reflect become 3. This is my x1, y1. Right? Now, because my gradient function by right is negative 2x plus 2, negative 2x minus 2, sorry, negative 2x minus 2. So I sub in. If I sub x equals to 0, dy dx equals to minus 2. Oh. So guys, just look at this. We are talking about a line. Okay, so I will lead by example. I'm definitely using a ruler. Okay, this is a ruler. Okay, the gradient is 2. The y-intercept, you can see the gradient is 2. The y-intercept is 3. Gradient is minus 2, my bad. Minus 2. Minus 2, minus 2. That's why the equation of the line is just y equals to negative 2x plus 3. Y equals to negative 2x plus 3. That is for question 3b. Question 3b. Is it okay? Now I'll just look at our body language and see if you all need extra time. Those who haven't do can literally do it now. Quite easier. It literally takes you about 10 minutes to do. Huh? Any question for me? Oh, okay. Can I go on? Toby, okay? Ariel? Can I? Jukai? Sia, okay? Sia, what are you doing? You're doing now. Okay. Question 4. Is the answer for question 4? Wait, 1 second. Okay, I'll put the question side by side. You can also look at the question inside your notes. This is question 4. Very easy. Just submit. Literally just submit. So, to find A, the answers are just there. Okay. But of course, let me talk about the outcome. To find A, you sub x equals 0. To find B and C, you sub y equals 0. To find D literally just read off. 2 comma minus 3. It's just a turning point. D is just a turning point. B is just the turning point. Okay? Can all can understand why this is a turning point? Can all? I will go through before. Okay. You can't see for me. Fall down. So that's question 4. So if all is okay, let me go to question 5. Everyone okay? 4, huh? Okay. Let me go to question 5. Okay. Question 5. You're supposed to draw 6 sine px plus 2. Okay. So if you look at 5a, for example, if you recall, for sine x, right? For sine x, right? What are the x-intercepts? The x-intercept, I think, is like, let me check. Basically, it's 0, 0, 0, 0, pi 0, and 2 pi 0, right? So if you go to sine 3x, this will become 0, 0, pi over 3, 0, 2 pi over 3, 0. Okay? But if you go to sine 3x plus 2, then if you go to 6 sine 3x plus 2, what you can consider is to draw this first. Okay? And draw 6 sine 3x plus 2. Yeah. So I think let me use the Are you having a problem with the translated graph? No. Okay, so okay, so my guess is these parts are okay, right? These parts are okay. So maybe what I'll do is I just go to the side, after a bit. Because there's no space on the graph. Right? If this is equal to 0, right? This is to find the x-intercept. Okay? This is the same as sine px plus 2 goes to 0. This is the same as sine px goes to negative 2 over 6. This is the same as sine px negative 1. What's my alpha? Is it correct? That's not. What's the sine inverse quantum? This one is wrong. I believe these two are wrong. I think these two are wrong. If I'm not wrong.
0.3.
0.34? 0.34. What's the other one?
0.33983.
0.33983. So this answer should be I plus. Can someone give me these two values? Can someone give me these two values? 3.4814. Second one?
5.944.
5.944. Timothy, can I ask you get these two values? No, you get. Oh, divide by 3. You can't see? Yeah, there was an emperor called Kanzi. You divide by 3 for. You divide by 3. See, divide by 3. What's the answer divide by 3? 1.16. 1.16. 5.9. This is about 1.9.
1.98.
Is it correct? Yours? So sorry. This one wrong. Gentlemen and ladies, the answer is 1.16 and 1.91. How come the answer can come up 3 times? Hey, stop turning around. Please stop. Where's your... So far, okay? What about 5B? Is 5B correct? Wrong also. Is the intercept wrong? Let's check. Yeah. This one is textbook answer. It's not me, it's not me. Equals to 1/4. So what is cosine inverse 1/4? May I borrow a calculator? Let me know. Don't be too calculative.
It's 1.31.
Thank you, sir. I love you. So what is x over 2? That means x over 2 equals to 1.31811. X equals to 2.6. 2.636. This number is 2.636. Why you so excited and seeing that? Mrs. Yap. Mrs. Anyway. Because your graph, okay, the intercept is 2.63. Pi is about 3.1415. So 2.636 so pi. Yes. Which one? Okay, 5C. Is 5C correct? Yeah. No. 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 Make so much noise, then still want to go toilet. Last week whole week never come, still want to go toilet. Huh? Okay, hurry. So do you know how to get the asymptotes? The original asymptotes for tangent x is x equals to pi over 2. So if you're thinking about tangent 3x, then basically 3x equals to pi over 2, which is why x is equals to pi over 6. Or pi over 2, 3 pi over 2, these are the asymptotes. So pi over 2, 3 pi over 2, you have pi over 6, 3 pi over 6. Okay? That's how you get the asymptotes. Okay, ma? So remember tangent not asymptotes. Tangent amplitude does not affect the shape of the curve. Okay, because tangent has no amplitude. Because tangent, if you multiply by 2, shape still the same. But unlike a sine cosine graph. Okay? So okay. Pass up to Sitong. Then we will do AFL 3. AFL3 is a bit shorter than AFL2. Okay. AFL3 is pretty easy. I think. Okay, I'll put it back. Reggie. Today is the 13, 14? 13. Today is 13. Come again? So let's look at AFL3. Okay. Thanks. Sorry. Guys, be nice, don't keep calling each other to shut up. Just tell them I say, please be quiet. Yeah, please be silent. So question 1, 9 over 3x minus 2. Yeah, question 9, you just take note, we differentiate f prime over fx. Use laws of logarithm. Use laws of logarithm. Right? Split the function up. Okay? Okay? Then you just remember that when you differentiate fx, differentiate ln of fx is the same as f prime over fx. Okay? Okay. Answer is right here. Question 2, same trick, same hint. Okay? The answer is just -3. Question 3. Question 3 is a mouthful. It's a long whoa. Question 3bi. Part 2. Yeah, that's the answer. That was what? That's my what? That's my stamp. But no. I put the answer here because I want those who are recording to be able to see. Oh. I put ANS answer. working, I will put a post-it. Oh, it's just a show question. Question 4 is just a show question. Answers, do not copy. Is question 1 okay? Guys, don't use quotient law or anything. I hope you're not using quotient rule. I saw some of you use quotient rule, I got fright. Okay, guys, like I said, use the loss of logarithm. What am I trying to say? When you differentiate, this is the same as ln 3x minus 2 cubed subtract ln 4 minus 5x squared. Do you remember we just did this last week? Can anyone not for me? We just did this last week. Okay. So don't use quotient rule. Don't use quotient rule. Always be smart. Be smart, be lazy. If you use quotient rule, please stop where you are, go back and trace the step. Okay? So your y is this. It's the same as this. By the power law of logarithm is 3x minus 2. You are not meant to have a hard life for this question. It's a very easy life. So this is 3 over 3x minus 2 minus negative 10x over 4 minus 5x squared. Very easy one. Very, very easy one. This is question 1, answer. Okay? Use the loss of logarithm. I say, okay, question 1 and 2, use the loss of logarithm. You should not need to use quotient rule. Alright? If you use, you will have a very hard time. Megan doing well. Okay. So bias, one more step. Bring the power law, bring it down. Bring down the 3. Yes. For which one? Second, 3.5. Here. 3.5 here. This one is the answer for 3.5. This one later lah, maybe later. Multiply by 2 over 2 plus. It's the same, but you need multiply. You need multiply. Yeah, this is question 1. So use the laws of logarithm, use the product law, use the quotient law, use the power law. Okay, not quotient rule. The answer is can combine. Because the question asks you I said put as a single bracket. Yes. Question? How do I show working for 3A? Okay. Oh, just write out the steps. So for example, f prime equals to differentiation of e minus cotangent 3 pi x. Then you write out answer. Yeah. But in this case, usually just the answer is fine. Yes. The x is included. Yes. Also, but you must remember this is E. Not bring down, but differentiate bring down. Oh. So not minus one, not minus one. So the formula, when you differentiate e power fx is equals to f prime e power fx. Oh, is it okay? Can I topic 5 part 3 notes? Yeah, but I treat this as fx. I treat this as fx. So if I differentiate, I also bring down because the x here is not a polynomial, it's not a true function. Alright, okay, minus cotangent 3 pi, what do I differentiate? So this one I differentiate, need to have chain rule. Differentiate minus cotangent is minus cosecant square 3 pi x. Differentiate the 3 pi x, inside got 3 pi. So minus 3 pi. When you differentiate cotangent 3 pi x, what do you get? There's a chain rule inside, right? You get minus 3. This is, so inside I show you. This is the derivative of cotangent 3 pi x. So it's 3 pi cosecant square 3 pi x. Okay? Yes, there's a bracket. So it's another layer of 3. Huh? Why you don't write bracket? Okay lah. I mean, okay. You're right. Okay, I should put bracket. Okay, let's be nice. Let's be nice. Okay. Yeah. Okay. Exam I find will. But AFL they always do all the nasty things. How do I get 3 pi? Let me show you. Okay. So here, first of all, okay, Megan, do you see? Okay. Let me try. Green color is 1 layer. Brown color is 1 layer. Pink color is another layer. Then, so if I differentiate brown, green, if I differentiate, first of all, layer 1 is e power something. Layer 2, layer 1, layer 2 is minus cotangent something. Layer 3 is 3 pi x. So if I differentiate e something, I'll get e something. Okay, if I differentiate minus cotangent, I get minus cosecant square. If I differentiate 3 pi x, I get 3 pi. Then, so that's why if I combine all together, if I differentiate layer 1 times differentiate layer 2 times differentiate layer 3, okay? 3 pi times minus cosecant square times e power. Okay? Yes. E power, what's the e power? What's in the e power? Whatever you saw, whatever is here, you copy. Okay, whatever you said, you copy. Okay? Cotangent minus 3 pi x. Yes, I got differentiate. I differentiate in other layers. This is 1 layer. I never overlap. Okay, so when you differentiate e power something, it's e power something, right?
Yeah.
Yes, it's the same. So based on the form notes, you remember topic 5 part 3, when you differentiate e to the power of fx, it is e power fx. Okay? Okay? No, that's part 2. Part 2, sorry. My brain hang for a while. Yeah. Differentiate e power fx. Okay? It's okay. I recorded. You can watch it. It's all uploaded. I just haven't sent to you. It's just I've been uploading it, but I haven't got time to decorate the thumbnail. Stop scratching your. Be a bit more gentleman. Yeah. Get a bigger shirt, please, general. The muscles are bursting out. Get your one looks too tight. Yeah. You look uncomfortable. I don't think you can study well. Joshua, keep quiet, face the front. Never ask you to give comment. Okay. Huh? What is it? Your mom also said the same thing about him. Yes, but there's a negative in front. So there's a negative that comes from differentiating minus cotangent. Okay, cotangent, when you differentiate, right? Oh, okay, positive. Wow, okay, this is confusing. Yeah. Because cotangent itself, right, when you differentiate, it's minus cosecant squared. And minus cotangent will become positive cosecant squared. Oh, anything that's a co, right, Zoe? Anything that's a co, differentiate will come out negative. Okay? Differentiate cosine. Cosine x, right, you'll come out negative sign. Cotangent, it will come out minus cosecant. A lot of negativity. Anything that's co, you differentiate, will have a minus sign. Okay, guys, you can write this down. It's a pattern. Anything that has a co at the front, you differentiate, will have a minus sign. Cosine become minus sign. Cotangent is minus cosecant square. Or yeah, it's fine. Because it's only 2 marks. It's probably. Then for B part 1 is the same. Apply the laws of logarithm. Okay, B part 1. Which one? B part 2. Okay, so B part 2, right? You're supposed to differentiate log. Use the law of logarithm, bring it down first. Yeah, okay, so you can use the laws of logarithm, right? So Megan, can I say this for B part 2? Okay, I think B part 1 is easy now. B part 2, if I'm differentiating, Megan, can I say that this is the same as this? I bring out the 2. Okay? Does the 2 doesn't affect this doesn't affect this, right? This doesn't affect this, right? Not related, right? The power does not affect 2, okay. So I bring out the 2. Can I say that by the Powers law of logarithm, this is the same as differentiating 2 sine 2x multiply 2 ln. Okay, sorry. Let me leave the 2 inside. 2 ln square root x plus 1x. Can I say it this way? So because Megan, I want to show you how similar and related this is to one of your earlier friends, which you have already found the differentiation. Okay? Can you see that this is the same as this? Can you see that? Oh my God. Okay? Yes, this is the same because of logarithm. Huh? I just keep it with the ln because I keep it with the ln because I keep this with this, right? Because then it will look exactly. This will look exactly. I want this to look like part 1. I want to look like part 1. I want to look like 3A. 3B part 1. Can you see? I want this to look like 3B part 1. So doesn't matter, 2 can be left out for differentiation. Because when you differentiate A fx, right? A scalar multiple need not take part in the differentiation. It's the same as A differentiating fx. Oh, cannot. Yes. B part 2. 1 second. Here. Okay. Answer is here. Wait. So then what am I trying to tell you guys? This, let's say if this you treat this like U, this is V, right? Then this is just your V prime. Because this is exactly from, oh, is it very dark? Look at us. See, cannot see. Let me write again. Let me write. Okay, I didn't know. Sorry, I never see a screen. Can you all see that, guys? This is from part 1. From part B, part 1. So from B part 1, you know this, right? From B part 1, let's say if I call this my B, right? From B part 1, B prime would be equals to 1 over x plus 1 minus 2 over x. If I call this U, then U prime is just 2 cos 2x. Okay? Is that okay? You all understand the connection? That this is from B part 1. B part 1. Can you see B part 1? We have differentiated log, right? So if I call this, because what am I going to do here? What rule? What rule is it called? Two things times together. What rule? Product rule. Very good. I'm going to apply product rule. So that's why you can see that it's going to, what's going to happen is basically product rule. Okay, I'm going to apply product rule. Let me write it in blue. Applying product rule. Applying product rule. Okay, applying product rule. U prime times B plus B prime times U. Okay. So you can see U prime, okay, sine 2x U times B. See, time's up already. Haven't off. Okay. Time flies when you're doing math. Okay, huh? Can off. Then you simplify. Okay. That's the answer. This is 3B. Okay. Again. Same thing. I just show. I just show you the whole thing. Okay, we will continue tomorrow. Please bring this tomorrow. Or if you are done, you can also pass to me. Okay? Oh, sorry. Thank you. That's all. Tomorrow is assignment. Ready? Assignment? Today got NSG? Today don't have. Try your best. At least 5 questions, you do 3. Oh, okay. Can. Most important is just keep consistent every day. Good. Okay. Okay, that's all. Thank you, class. Hey, thank you, class.